Once again, good afternoon and welcome. I'm Keith Simon. I'm the Senior Development Manager for Airmaster Fan. And today we're going to give you a little presentation about ventilation. The idea is to provide background information, and if nothing else, give you ideas as to the questions that you need to ask in order to evaluate a building for ventilation. For those of you in the Witness Protection Program, today's presentation is being recorded, so you might want to keep that in mind. Why ventilate? Well, I think most people would love to have their manufacturing facilities air conditioned. It most often just isn't feasible. Not only is the cost of the air conditioning equipment itself an obstacle, but the operational cost would also be high. So ventilation is the only realistic way of providing a level of comfort in a building. And ventilation is air movement in or out of a building, and is often, as I said, the only realistic method of controlling the environment. A ventilation system not only provides fresh air, but it can also address other issues such as heat control, contamination, and humidity. Some of these issues are a matter of comfort, but some are also a matter of satisfying regulations. Specifically, contamination and odors can be a particular problem. But today, there's also another good reason. Today, dilution, which is what ventilation provides, can also be an effective solution to help prevent the spread of the coronavirus. If you didn't attend our recent web presentation on proper use of air moving equipment during the pandemic, you should be able to find a copy of the presentation on Airmaster's website. So the solution is dilution or ventilation. Just for a moment, let's consider a short, narrow, long room that's just the same size as the discharge of a large fan. That fan is blowing or sucking air into or out of the room, and barring the amount of time that it takes the air to traverse the length of the room, this is just about as close to having a fan replace the air in a room. Obviously, however, few people would want to work in the middle of an air tunnel. So, with the exception of that slightly bizarre case, ventilation is dilution. It brings in outside air where it mixes with the room air, and the mixture over time becomes similar in character to the outside air. Keep in mind that the conditions inside are never going to become any better than that found outside. If it's hot outside, then eventually it's going to become hot inside. So the primary tool and measure of ventilation is air changes per hour, which is often referred to as ACH. This is the starting point in the design of a ventilation system. But keep in mind the value for ACH, some of which are shown in the box at the right, is just an estimated value. As you can see from the numbers, there's a large variation in the recommended air changes per hour. So how do you decide on a single value? Well, you look around at what's going on in the building. For instance, a garage that repairs only 6 cars in a large building is probably around a 20. Garage repair being shown above as 20 to 30. On the other hand, a similar size garage that is repairing 12 diesel trucks would probably be a 30. So these are starting guidelines to give you a good estimation of the amount of air that you're going to need to provide for ventilation. The only real danger if one airs on the high side with air changes per hour is that the potential that all the fans won't be used on a regular basis, which is, quite frankly, by no means the end of the world. One other note, it's not necessary that an entire building uses the same value for air changes per hour. particularly where there are walls or large obstructions that effectively separate sections, then each section should be evaluated as a separate entity. This can be accomplished even where there are no walls by very careful placement of fans and the thought being given to airflow patterns. Take a bakery, for example, and the air changes per hour for bakery is shown to be 20 to 30. That value, or those values, are generally designed to handle the heat of a large oven. But in some cases, you may also have a mixing room where the requirements are quite different than the 20 to 30 air changes per hour for the room holding the large oven. And in fact, in a mixing room, you might want to give consideration to the fan being explosion proof because the ingredients are often potentially explosive. So let's look at some of the special cases that were mentioned at the beginning. The first one being heat. Heat is a driving force for companies to install ventilation equipment. In some ways, traditional hot locations like foundries, Ford shops, glass plants, and so are easier ones. That's because the value for air changes per hour for these operations are already elevated to take into account large heat emissions. It's what appears to be a standard factory where problems can arise. If you look at a generic plant, and let's just for example's sake, assume that there's 200, in aggregate, 250 horsepower worth of motors. As it shows there, that heat from the 250 horsepower motors can elevate the temperature by 6 degrees per minute. Now that assumes that all the heat is going into the air in the building rather than warming the contents. But nonetheless, a large number of motors can substantially add a lot of heat. So any time you go into a factory, take a look, see if there's a large number of motors, see how big they are, because this information can provide guidance in selecting an air change per hour that's appropriate for that heat load. Of course, simple thermal comfort for workers is also a driving force in acquiring ventilation equipment. One thing that is surprising, often people don't start operating ventilation fans until it's already become hot both inside and out. That's a lost opportunity, particularly in northern states where the temperature drops at night. Take advantage of free cooling by turning the fans on first thing in the morning or even some period of time before people arrive in your building. Take advantage of the free cooling, then turn the fans off until the inside temperature exceeds the outside, and then turn them back on. Another special case is humidity. While it's not as common as heat, high humidity can cause worker discomfort at temperatures that would otherwise not present a problem. There are typical facilities such as agricultural processing, laundry, ceramics, paper making, corrugated, where large amounts of water are used or steam is used, and that water or steam is going into the air. If you see this, ask about the amounts of water used or steam used, and then we'll be happy to provide you assistance in properly sizing the equipment. Actually, a somewhat more common case, although it's listed here as a special case, are vapors and odors. One thing to mention, dilution ventilation is not a substitute for source capture of harmful vapor. And source capture means to capture vapors, odors, whatever, or any type of contaminant right at the source using hoods and ducting so as to capture the offending contaminants before they become mixed in the room air. Solution ventilation should be used in those cases as an additional level of protection. Often there are operations that you'll find where the amounts and location of use does not lend itself to source capture. And in these locations, ventilation is the proper method to employ. One thing, make sure to identify chemicals or chemical used. Just solvents is not sufficient because the maximum allowable level for different solvents is quite different. If at all possible, just obtain a copy of the safety data sheets, and that'll give us the information we need. Don't worry too much about the formulas shown on the slide. They're there just to provide you an idea of the calculations that would be used. As a quick explanation, release rate is straightforward. How many ounces, gallons, or pounds of material is released into the air during a given time period? An hour, a shift, whatever. The maximum allowable concentration, which is shown, is either what is known as a threshold limit value, which is a concentration that is set up as an amount by the American Society of Governmental Hygienists that's based on the toxicity of the material. Or it could be a lower explosive limit, which is the amount of material that's required to actually have an explosion. All of that type of information is available from published information, but we have the sources at hand and we'll be happy to assist you anytime you run into something where it's a solvent or other hazardous material. And while we're on the subject of materials that are potentially combustible or explosive, make sure that you note that and go ahead and ask us for assistance in sizing those types of systems. One alternate for air changes per hour, or the use of air changes per hour, is the potential for having a fairly small room with a high occupancy. Doesn't happen often, but you should be aware about it, just if you happen to stumble across something like that. This is almost always some sort of assembly operation where a large number of workers are in a relatively small space. We are recommending 60 CFM per person, which is well above the standard ASHRAE recommendation, but we recommend it primarily because of the current pandemic. It's also applicable where you have widespread operations like soldering or welding that are part of the assembly process. So one of the things that we do stress is keep it simple. Panel fans are by no means the only possible ventilation product that can provide building fresh air. For instance, think about roof ventilators. But panel fans are almost always the best starting point because they're somewhat simpler to install. And they are available in a huge range of sizes, different power supply configurations, and with the necessary accessories for a complete installation. One thing to keep in mind, particularly with panel fans, is that the space between structural members is always a determining factor in sizing panel fans. And you can see in the picture all the structure that's supporting that metal building and the space between those structures. Yes, it's possible to reroute or change the structure, but the cost of doing so almost always exceeds the additional cost of utilizing more smaller fans. So just keep this in mind because it's a reasonably important issue. We'd like to make the process of preparing a quote for ventilation products easy. So we are in the process of creating a spreadsheet that automates the process. We are currently about to start beta testing, and we hope to have this tool for you in the near future. Okay, a couple more pointers. You really don't want to fight Mother Nature. Mother Nature always wins. So keep in mind, air is going to go where it wants to go, not where you want it to go. It's always going to take the path of least resistance. And if this is a short circuit directly from an opening to an exhaust fan, that's what's going to happen. And warm air or humid air is less dense and will rise, always. If one mounts a panel fan near the floor, then it's going to pull the air from that elevation preferentially. This means that the air above it is going to remain hot and stagnant. This might be acceptable in some cases, but beware. Something that even experienced ventilation engineers often neglect is prevailing winds and their effect on how well a fan is going to operate. When there is a choice, isn't it wise not to try and fight Mother Nature? But the biggest and absolutely the most common mistake is not allowing for air entry into a building to replace the air that is being exhausted. Particularly during cooler months, how many times have you tried to open a plant door only to find that it's being sucked closed? Just my personal belief, but I think probably half the plants in the United States have negative pressure problems that are caused by fans that are operating without a source of air to replace the air that's trying to be exhausted. And yes, I can tell you that is true of Airmaster's plant at times as well. So the solution to that problem, remember the louvers. When you exhaust, you must supply. For a ventilation installation using exhaust fans, louvers are the solution, and they aren't particularly difficult. Choose a size based on the physical structure of the building, which is exactly what you were doing for the panel fans. Then divide the total flow of all the exhaust units by 700. This is based on the pressure required to pull the air through the louvers. That will give you a total open area for the louvers, and open air area is about 35% of the actual dimensions, but it's also shown in the Airmaster catalog. And so you divide the open area by per unit or by the number of units, and it will give you the number of units required. So a fairly simple process that will solve a lot of major problems. So short and sweet. Today's presentation is just the first of a series on the subject of ventilation. We do hope, however, that we have provided you some background which will raise your awareness and you'll know what questions to ask. We recognize that there are all sorts of special cases and exceptions when designing a ventilation system, and we are truly here to help. Call on us anytime, but for now, I'd love to address any questions that you might have.